Hey, welcome back to the Relevant Combustion Corner. I'm Jeff Lohrfing, Combustion Business Development Manager here at Relevant Industrial, and I'm so glad you're here. So sit back and relax while we talk about and bring you some of the hottest topics in the world of combustion.
Alrighty, hi, I'm Dylan McMahan, Engineering Operations Manager with Relevant Industrial. We have Mr. Jeff Lohrfing here.
Jeff Lohrfing, Business Development Manager for the combustion business here at Relevant Industrial.
Absolutely. So today we just wanted to get together and talk a little bit about BMS, kind of what role it plays in a combustion system and the facilities we serve, as well a little bit about fuel-air ratio control, what we can do kind of in that space, and we'll just jump right in here.
Yeah, thanks, Dylan. So, our day in and day out, we do a lot with burner management and fuel air ratio control. We're called in a lot to consult, right? And to talk to customers, whether they're doing a greenfield project or an upgrade. The BMS part, because it's so code driven, right? We got 3 codes that we really deal with in our industry with NFPA 85, 86, and 87. So a lot of what we talk about is really around these codes that we need to comply with from a BMS perspective. So, the BMS, and a lot of people will do this, they tend to kind of bundle fuel air ratio control and burner management all into one discussion. But in my mind, burner management is the safety portion of the system.
Absolutely.
Right? So it's going to handle the safe startup and shutdown of the burner. Whereas once we've lit the burner's at low fire, we hand it off to the fuel air ratio control system. And so it kind of becomes a gray area sometimes about the role that each one of these plays. So burner management, typical burner management sequence is, the systems power up. They go through a safe start check. They do some internal diagnostics on the flame safeguard themselves. One of the things they check for is the cleanliness of power.
Right.
That's a code-driven specification, as well as do I or do I not have a flame on my target burner?
Yes,
right? Yes. So obviously we don't want to light a burner that already has a flame present at our target burner, right?
Right.
So at that point, the burner management will then go into standby mode and wait on what we call a call for heat. So the process then will call for heat, and that can be something as simple as an operator pushing a start burner push button, or the process saying, hey, we need heat, right?
Right.
And so at that point, the system will then go through pre-ignition interlocks. It goes out and checks the position of the safety shutoff valves. It checks for its running limits, and then it'll go into a purge sequence. And at that point, the system will then, to get the system at a high fire state, so we're moving that calculated amount of air that we need for our purge calculation that we've done. And code tells us that we've got to do 4 volumetric air changes in our combustion chamber to meet code requirements. So once we've successfully purged the system, and all the limits upstream have maintained healthy that whole time, because if we lose any of those limits, we've got to go back and recycle. That's just the way.
The safety controllers monitoring all that
the whole time.
Right.
Absolutely. So once we get to that point, we go to what we call PTFI. So the system will then take itself to a low fire state. This is where we try to establish a pilot at the burner, right?
Yes.
So we're going to energize the igniter. We're going to energize our pilot fuel gas valves. And this is where our flame detection comes into play, right? We call our flame detectors the first line of defense, right? Because if we're not positively identifying that we have a flame at our target burner, we obviously don't want to be dumping fuel into said chamber.
Yeah.
And so at that point,
a little bit of a safety hazard.
A little bit of a safety hazard.
Environmental, all that fun stuff.
Exactly.
Yes, sir.
So we energize the solenoids for the pilot. We energize the igniter. We detect a flame. At that point, we move to what we call MTFI, main trial for ignition. This is where we're going to try to put main gas to our burner in a low fire state. And that's why we have to prove that we have our fuel valves and our air valves at low fire. We wouldn't want to open up block valves with the control valve setting at 60, 70%. Right. That would initiate what we call a hard start. Right. Mm-hmm. And so that's why we need to verify that low fire state of our control valve. At that point in time, we energize the main gas valves, and
on to the next step.
On to the next step, we verify that our scanner, our flame detection device, is still seeing flame at the target burner. And depending on what kind of pilot we have, whether it's interrupted or intermittent, we'll either shut that pilot off, or that pilot will stay running for the duration of the run. And this is the part where I think a lot of people get confused. So at this point, we've safely lit that burner. Okay, that's the burner management system's role in the combustion system.
Right.
At that point, that's where the fuel air ratio control system takes over for the demands of the process.
That's actually what I was curious about. So can you talk about some of the different fuel air ratio controls that we deal with and kind of the pros and cons around some of that?
Absolutely. So we've safely lit that burner. That burner management system is going to manage and monitor those critical running limits, your gas pressures, your flows, anything relative to that burner safely firing.
Right.
It's going to do that consistently in the background while the combustion control system takes over. So the three types that we primarily deal with are a linkage style system, which there's a lot of linkage still left out there, right?
So you've seen some of that older stuff out there.
There's a lot of it out there. So a linkage style system that we have direct coupled, where we have an actuator actually directly coupled to a valve, whether it be gas or air. And then we have direct coupled with fuel air ratio control, where we actually can control the fuel and the air independent of each other. And we really lean into that technology when we're in emissions projects or emissions opportunities. We've got to be able to control that fuel and air independently. So kind of taking it back, linkage is functional. It's been around for years. There's a lot of it still out there, but there's a lot of opportunity to take those linkage systems and just upgrade them to a direct coupled system, right?
Sure.
The efficiencies that you gain off of an actuator that's moving at 1/10 of a degree, you just inherently are going to recognize efficiencies there. Linkage, like anything mechanical, over time is going to wear, right? We're going to get hysteresis. We're going to get the repeatability of that is going to diminish over time. And so
fade.
Where we initially set that burner up on startup or commissioning a year or so later, is that gas valve or air valve really where it was when we set that burner up initially? Probably not. So hence the advantages of a direct coupled system. When you take direct coupled and then marry it to a fuel air ratio control system, now we've kind of taken it to a whole nother level, because the efficiency gains, take an exponential increase. And like I mentioned, we're always going to lean into fuel air ratio control on low emissions applications where we can control that fuel and that air independently. And the reason we have to do that is once we fire a burner up that has parallel positioning control, we have to create a combustion curve.
Right.
Okay? And so whether you're doing that inside of a PLC or you're using a system like our SmartLink MRV system, it takes the output of the temp controller, and then based on that output, it's going to set the fuel in the air at a specific point, right?
Right.
So when you're commissioning the burner, you have an analyzer in the stack monitoring your emissions, and you create a combustion curve. So you're going to create a curve across the complete firing rate of that burner. And so wherever that temp controller goes, fuel and air knows where to go. So the reason it's important with emissions is generally we're chasing NOx and CO.
Right. Yes, sir.
And so it's funny, and follow me here, it sounds confusing, but the cooler the flame, the lower the NOx, the higher the CO. The hotter the flame, the lower the CO, the higher the NOx. So you have to sit and add fuel and air across the firing rate of that burner to establish the emissions that you're looking for out of your stack. So at some point in the fuel curve, if you're not quite meeting that NOx target that you're after, you can go and add air without affecting the gas, right? Because they're independent of each other.
Instead of that linked system.
Correct.
Perfect sense.
So here again, that's, three types that we deal with primarily. And they all have their pros and their cons, right? And we're always it makes for good discussion to talk about folks that are trying to save gas, right? They're trying to burn cleaner, and that whole green initiative, I think everybody's trying to do it better than the next guy, right? And for the environment. Yeah. So it's always a good point for us to discuss the capabilities of our fuel air ratio control system. So
absolutely,
those two systems are really kind of the core of a combustion system. The burner management, here again, monitoring the safety and the operation of the burner. Here again, if our scanner or our flame sensing device is not seeing a flame, we're going to shut that fuel delivery system down, right? Okay. If we get a high gas pressure, low gas pressure on our pipe train, we're shutting that burner down. So it doesn't really matter what process needs, you hate saying that in front of the operators, It doesn't matter. This thing is going to stand watch 24/7,
right?
And monitor the safety integrity of that of that burner. So
very cool. Very cool. So what are some ways that Relevant can help in regards to some of this, the BMS and the fuel air ratio controls?
Yeah. So we have very comprehensive portfolio around flame safeguard, right? Our Honeywell Rhythm 7800, that's a tried and true platform, been around for many, many years.
There might be one in that box, right?
You want to buy Friday behind me, right? So you go pop open the control panel.
Yes, sir.
On the channel, you're probably gonna be face to face with an RM 7800 in some way. Fuel air ratio control, like I mentioned, our SmartLink MRV system, very industrial, very robust system that we use a lot here.
Right. Seen it quite a bit. So some of that hanging around in some of these demos as well.
We do. We lean in a lot with the SmartLink MRV, but very comprehensive portfolio around the safety and control of our burners.
Well, Mr. Jeff, really appreciate your time today, sir. Thanks for going through BMS and fuel air ratio controls. Feel a little bit smarter, as it's a little bit overwhelming to try to take all this stuff in all the time, but really appreciate the extra insight you provide.
Yeah, no, absolutely. Thank you for joining us, and we'll see you next time on the Combustion Corner.
Awesome.